Welcome everyone. So today I'm going to talk about container and Kubernetes. But before we dive into what container and Kubernetes is, let us go back and understand what application is. But briefly, to touch on what I'm going to cover is about application and its hosting, and then we'll talk about the Docker. That's the de facto container platform. For quite some time, Docker dominated the industry and have been ruling even today. Then we'll talk about container registry, which is an important area. We need to understand why it is required, without which we cannot use our container. And then we will have the Kubernetes, the orchestrator to manage multiple containers in a typical microservices world. And then followed by Azure Kubernetes Services, which is the Azure offering fully managed Kubernetes service with all sort of RBACs, networking, storage, and everything else you need to run the Kubernetes. Now, some time back, I created a content where I kind of created the step-by-step guideline for people who are willing to pick up the Kubernetes as their skill set. And I have thought through and have experienced a similar thing while trying to upgrade myself on Kubernetes. And I kind of build off this flow of learning. So I think that to learn Kubernetes, you need to learn the Linux basic command because you will encounter the Linux console every now and then while working with the Kubernetes. A little bit of bash script knowledge is helpful. It is not a mandatory thing, but no knowledge is a bad knowledge. So if you encounter anything which you are where you need to write a bash script, if you have the fair understanding of the bash script, it becomes easier. Vim, the VI editor, the VI modified editor is the absolute important thing because that's through which you will encounter with a lot of YAML editing. If you are not comfortable running commands inside of Vim because Vim is not a typical text editor, it has a different set of hotkeys. And then YAML is definitely the reproducible infrastructure as a code or I deployment scripts, you can say, which is common in the Kubernetes world. While you're learning the Kubernetes, you don't need to learn Docker because Kubernetes doesn't require you to know anything about Docker. But having the understanding of how Docker works helps. But if you don't, let's say, you have zero knowledge on Docker, you can still be master in Kubernetes as well, right? And then definitely the concept of Kubernetes is important to work on Kubernetes. So that's the step-by-step guideline for somebody who wants to pick up Kubernetes as their next skill. Now to talk about application, right? So we need to understand like what application is and how application works. So let me share a screen where we can talk about the application concept. Now, anytime somebody talks about an application, a software application, right? It is nothing but a program which runs on a computer. Computer program which runs on a computer. Now, you need a PC or a server to run it. That's typically an application is. If you go very complex, then you have something called a database, which stores the data for that application. It can have many other things also. But think of it a code which runs in a computer. Now, there are different types of application we use, right? One is a desktop application, which an independent standalone sort of application, let's say Windows Media Player, VLC, etc., which are desktop application. There are distributed application, which could be a desktop application. We call it client server, which basically connects to a centralized database. And then people can connect the application from using the database. Many people can open their desktop and start working on that application. So in the early 20s, 200, we have used this concept pretty heavily. A lot of application, and this also is known as thick client, dominated in the world of Windows. Many of us have used this Windows-based thick client application, which used to connect to a database and then get you things from there. Now that's what kind of the application is. Now, when I start saying that distributed database, now you start imagining each of them actually represents a sort of a machine. So if I consider this green as a machine, these are all individual machines, right? Now, if it is a client server application, these are all user desktop, right? This may be the server component, and this is user. And if it is a business critical application, instead of one server, you can have replicas, which mean just to have a copy and have a synchronization. And as it grows bigger, the number of server increases. So the whole intent of this, say, to talk about like you need lots and lots of server. And when you need lots and lots of server, you need a life cycle, which means that depending on the type of the server you are using, they need to be upgraded, correct? Which means that typically a 3-year time frame. So if you think from this perspective, it's an system admin job. So if I say system admin job, so it's a huge data center maintenance. Not many company are setting up their own data centers nowadays. Even if they used to have data center, they are now moving to cloud. Why? A cloud offers you something called virtualization, through which you basically get a virtualized environment. So you do not get the dedicated hardware generally. You get a virtualized environment. In Windows world, we call it Hyper-V. And then in that virtual environment, you run an operating system, you configure the runtime, you install your application, etc., etc. So it's kind of like a machine, but not a real machine, a virtual machine given to you, and as many you want, you can get them, and they basically definitely run on top of a physical hardware. Okay, so this is what how people have moved from dedicated hardware based server to a virtual server. Now, doing the virtual server is, think of it like an apartment complex. You have a large area where you have a high-rise building. Each of the floor is a single apartment, so each of them has a virtual machine running. So in a building, you basically typically have multiple families living independently in an isolation with their own way of living, but the whole building is the same. So virtualized environment is like that. So it's a single rack, but you may be running, let's say, Windows 2012. Someone may be running a Linux. You may be running Windows 10. So these are all independent, isolated, sharing the kind of total number of RAM and the core. So when you create a virtual machine, so let's say this machine has got 16 GB RAM, you allocate 4 GB to this. So the remaining will be 12 GB. You allocate 4 GB. The remaining will be 8 GB, and you allocate 4 GB, so the remaining will be 4 GB. So that's how you share. So once you create a virtual machine, the share of the RAM goes to that virtual machine. Now, if you let's say shut down the virtual machine, this RAM still blocked. So it's kind of dedicating. So it's think of it like an apartment complex. A floor is given to someone. They are not living there. They just locked the house and went out in some place. It is unusable. The capacity of the house is not available for anybody because it is a dedicated place for someone who procured it, purchased it, right? So in the same context, the core also remains same. So it basically produces, let's say, 2 core given. So it reduces from there. Maybe I need 4 core. Maybe I need 6 core. So depending on the type and kind of workload I'm running, I'll keep allocating the core and it will exhaust the limit. And it says that, sorry, I cannot create any more VM because my hardware capacity has exhausted. So that's the kind of like the model how the virtualized environment works. So it is definitely something the foundation of the cloud today. So it is not going to go away. But from a typical application perspective, right? Sometimes people wanted little more optimization from an infrastructure perspective. So for a simple static application, let's say it's a static website, when I need to create a Linux or Windows VM dedicating, let's say 4 GB of RAM, can I use something like a shared, a small, which is not dedicated and then it's not very common, like let's not block the whole thing for a simple purpose. So the concept of sharing the kernel came in the picture. Now with this concept, here, each of them has their own OS kernel, separate. Now that's why you can create, let's say in the same rack, a Linux VM, a Windows VM, a different version of Windows VM. Now in the concept of kernel, we say that, you know what, I only give you the code and the library, whichever library runtime I'm using, code and library. That's the isolation I have, and it will run. Now, if I have to say that this is a Linux kernel, these are all Linux. It cannot have Windows. Now, we can run Windows container, but then we need a Windows kernel. And then we can run Windows container only on that. That's the only limitation from a container perspective. Now, these are all very small scale. Sometimes they are in MBs. Whereas in the virtual hard disk space, if you say the VHD, they are in GBs, generally in GBs and multiple GBs, right? So it's definitely heavyweight. This is definitely lightweight. Now, if the container is not running, it is not using any resource. So it is like having the video file stored in your machine. If you don't play the video, it's not going to consume your GPU, CPU, etc. Correct? So the moment you play the video, then it starts consuming the GPU, CPU. So it's like that. Container is like that. So that's the kind of like the movement we have done from a dedicated hardware-based machine to a virtualized machine to a container-based machine, right? You can see that progress. Now let me go back and switch to the slide. And this is where I'm gonna, this is the definition which say the computer program that runs on a computer is my definition. That may not be the right one, but it captures the essence of the application concept. Hosting an application means dedicated server, one or more, or virtualized environment. And there are challenges, as I said, like it works. It's not like it's not even the cloud platform you see today, all the public cloud platform built on top of virtualization. So all the high level services you get, those machines are virtual machines against which they run, but you don't need to know, right? That's how they manage most of the services today. The abstraction is on top of the virtual machine. Now, there's a couple of debates like why we need container. Now, definitely, it's a lightweight. It's a zipped form of your application with its runtime and the code, which means that think of it like a fridge. You take a fridge from one location to another location, you plug it in, it works. It works wherever it matches the electricity supply, right? It works everywhere. It doesn't really matter on which color you have in your wall, or is it in the first floor or the ground, second floor, etc. It works everywhere. Container is like that. Now, those who come from the development background knows that there's always used to be a debate between developer and the ops. Developer will always claim that the application works in my machine, whereas the ops or the tester will come back saying that it's not working because it might miss some, let's say, version library, or version is not matching because the installed copy in the developer machine, the dependencies and libraries are basically done. It's not like sometime, most of the time, it used to be that case. So it was very difficult conversation to have. Uh, that was the common analogy here in the developer thing. It's say it runs in my machine. Go figure it out, right? And they will show you it's running. So you can't argue that, right? But that doesn't really solve the problem of your application is not running. So the portability was an issue. So we couldn't do much because um, we need to try out many things. And sometime might be it's because it's built over a period of time. Developer might have installed 3 months back. I forgot about it, that dependency, and then that's not working. Right? So isolation helps you even if that shares the content kernel, but it has an isolation. Using a typical Linux isolation model, it uses that. And then it is efficient and it is agile also. And sort of like standardizes the deployment process. So I say that I'll give you a package to install a software in Windows X version, and it will work in that version in every machine. So that's the kind of standardization you are doing with the container. It gives you much more capability. So things like that will, and it is very safe because the moment you build an image, it is a read-only copy. So you can create multiple copies, but it's an immutable one. But it is a read-only. So it is a difficult task for someone to inject a malicious code into this. Whereas if you run something in the virtual machine, anybody gets access to the virtual machine can punch in the code, right? So the modification of the virtual machine is sort of easier than container because you put the container in a container registry, you protect it, nobody has access to it unless somebody downloads that, modifies, and puts it back. And then definitely you need a lot more access to do that. It is quite impossible to modify that. So that's what gives you a lot of sense of secure feeling, right? Which essentially is required for any application development, right? It's like an installer package you can think of. Now, from a container security perspective, right, we have got a lot of points. It basically an isolated environment, right? And then it gives you a layered file system. So we can go in depth about the container security. But in a nutshell, from an enterprise perspective, we have to realize and understand that it, it takes care of most of the thing, and that's why more and more enterprises are using this container as their default application deployment platform since few years. Now, to talk about container, we need to talk about Docker because Docker is the pioneer in the container industry. They come up with the container back in March 2012. And then for developers, they also built something called Docker Engine, which allows you to run a small scale Docker desktop in your machine. It can run on Linux and Windows. And then you can do your development. That means build your Docker images, test things in the local machine. You don't need to rely on the production grade deployment, right? That becomes kind of easier for the developer, right? You kind of enable the developer to work on something which they love to work on in their local machine, right? So let's have a look into that Docker as kind of an understanding of how it works. So let me switch to my demo machine. Um, okay, now there are a couple of ways by which you can run Docker. So I prefer to run the Docker in my local machine, that is Docker desktop. So you can use the WSL, that is a Windows subsystem for Linux, to and then just install the Docker over there. So I use Ubuntu as my operating system. So there's an instruction given in the Ubuntu to run that. So let me go and share that. Now this is the Windows subsystem for Linux running in my local machine. Now for me to run a Docker, I need to first run the Docker service. All right, let's keep it running side by side. Now, once you follow the instruction from Docker deployment desktop, so if you say that install Docker engine on Ubuntu, it basically takes you to the Docker documentation. So you just need to follow based on which operating system you're using. So it supports multiple operating systems. So you can take any operating system and install it. So I just follow the instruction and install the Docker. If it is overwhelming, that means you cannot really spend time on installing these components. Just use the killer quota, which I'm going to show later, which is a browser-based playground for you to try out things. You don't need any installation. You just need an internet connection. That's it. So it's basically have a step-by-step guidance, right? And you do all the sort of things, make sure it works. It is probably one-time activity, and then you have to keep updating that. Now, once you install the Docker, it installs something called a Docker CLI. If you type Docker, that's the Docker CLI. So it comes with set of commands, you can see, very few of them, right? These are the commands which you're gonna use when you work with Docker. Okay, that's the set of commands. Now let me walk you through with some of the commands. Now, as the Docker says, so you can say that, let's see that Docker, I should find that, yes, Docker V. So I'll say Docker minus V. So that's the Docker version. So I'm running the Docker version 24.0.7. And then if you say that Docker stats, that will talk about the statistics. So it gives you some number. All right. Now, Docker is an engine where you need some Docker image. Now, the first in the if you follow the documentation, in the first document, it says that you have got the Docker desktop running. You need an image. That means all the application code and its runtime to run it. So to see what all Docker container running in your local machine, you can run Docker PS. If it doesn't show anything, but it shows the error, that means it's working fine. By doing -a, it will tell you like what is the dead container. That means you run the container, but it stops now. Now you can see that there is a name given and there is an ID. Okay, so if you take the ID and you want to clean it up because it's kind of consuming the space in your machine, so I can say docker kill uh, docker remove, and it's gonna remove this thing. Now if I say ps minus a, you don't find anything, so it's kind of clean now. Now you can say docker images, and you can see that there is an image which is nginx wg, which is kind of getting displayed over here. That's fine. So what I can do, I can say docker run, and if I use hello, now it's will tell you some step-by-step things, right? So I do not have access to Docker. So let's say Docker login. Yeah. Now if I say Docker run nginx, so it first tries to find the image locally. If it cannot, then it will go ahead and download from a Docker registry. Now, since I'm using Docker CLI, it will point me to the default registry, which is the Docker Hub. Okay, so it's now running. You can see that you are inside that. You are unable to do anything. We'll see how we can play with that. But let me first show you once it is successfully running. You can say Docker PS. No, -a. You'll find an nginx container now in the list 37 seconds ago. That means this is the command which I ran. Now, this is a dead container, so it's of no use. But if you want to, let's say, run a container, okay, nginx, but you run it in a background, we call it a daemon, or detached. You will find that it's just came out, it's not waiting. But now if I say docker ps, you'll find a container running. And if I say ps -a, you'll find two of them running. Okay, not running, one is stopped, one is running, right? You can see that it's called exited, and it is up for 10 seconds. That means there is a running container in the background. Now if I say docker exec, right, that means I want to execute, I want to go inside a Docker Hub. So I want to go inside the Docker Hub, and then I want to, let's say, go ahead and play with it. So let's say I say Docker ps, first get the name of the command. Okay, so let me copy the name. That's the name. Okay, let me see if it's copying. That's fine. So I'll say Docker exec, and then I say interactive terminal -i interactive terminal, and then give the name of the container which is running, and I'm going to open the bin sh, okay, the shell. If I do that, now I'm inside the container. Basically, that I did a SSH to the container. I can say pwd, it'll show me the working directory. I can say ls -a, I'll show me all the files. So that's fine. It is working. Now, do I have a curl command there? So it is installed. So I can pretty much run a curl because I know it's an Nginx container. It has got a .http localhost. It runs some index.html as a file. So let's run that. So I'll say http colon local host. Now you can see that there's an HTML file comes up. But that's not how you want typically an application to work. No, you don't ask people to write a command and run the Docker. So let's exit from here. So we are out now. Now if I say Docker PS, you will see that still it's running. Absolutely fine. I can just say Docker stop, and then I stop the container. It stops. Now I say Docker PS. It is not there. If I say Docker PS minus A, you will find two of them up and running, exited. So it's not running anymore, right? Fine, absolutely fine. Now let's see how I can run this Nginx container and open it in my local browser. Okay, so to do that, I need few things. I need, let's say, port mapping. So I know that Nginx container runs on a port 80 by default, and to expose that port in my local machine, I need to do a port mapping, right? So let's run that run command. So now if I say docker run, instead of me directly providing the Nginx, what I can do -p 80 80. So I'll use local port 8080, which will point to the port 80, and then I say Nginx, and I will run it in a detach mode -d. Okay. Now what I can do, I can happily open my browser and I say localhost 8080. And you can see that it's showing welcome Nginx. Just to prove that it is the same Nginx, I can just minimize it and I say docker ps docker stop and then determined Robinson. If you don't give the name, there is a switch to provide the name. It randomly gives you a name which is a custom name, right? Combination of some verb, some characteristic and the noun, and then sort of like it's now stopped. Now if I refresh this, it don't show up anymore because it's gone. I do the same command just to run it again, it'll come back. So that means now it feels like an application, right? So you have the browser through which you can access the application. Now let me show you how typically you build an image. Now coming to that image, so if I say images, you'll find that there are two images. One is Nginx WG. Nginx WG was created 42 hours ago. Nginx created 10 days ago. So Nginx created 10 days ago because I have downloaded it from in fact the CLI downloaded it from the hub. So it is showing you that date. So let me run few commands. If I clear it up and then I say that and to build an image, you need to build a Docker file. And how you define a Docker file is something we will understand. But you have seen that Nginx comes with a default page, some text. That page is index.html. Okay, so let's create an index.html and let me copy a text here from my note. And then I just say vim, let me say ls, and I say mkdir demo 1 demo 2 cd demo 2, and then I say that vim index.html, and here I'm going to paste it. So I say my custom Nginx page. Hello from custom Nginx page. Very simple HTML. I come out of that. It's saved. Just to check, it is saved. I just say that this is the index. Now I'm gonna replace that Nginx page with my page and build my own image. So it will be custom image taking the Nginx as its base image. To do that, you need a Docker file. So that's the instruction file through which you build a Docker image. So let me create a Docker file. If I say Docker file, the first command is very simple. So insert from Nginx. That's it. You don't do anything, it works. Now you can also explicitly say expose 30, 80, or you just leave it like that. Just this much. Okay. If you come out and then say Docker images, just to see what all images are there, let me delete all of them. Okay. Docker RMI. That means in deleting the image. So I will say that image ID. So you can copy the ID here and it deletes that. And then you can even type the first few letters. Let's say E47 should be enough. Unable to delete because there is something running probably. So Docker PS, there is running Docker stop. And I say that this one stopped it. Now if I delete it, dash dash force, it's gonna delete it. Docker ps minus a, it's gonna show me that Docker rm, and then let me run a command to clean up all the thing. Docker ps minus aq, it's gonna delete that Docker ps minus a. You don't see now any Docker either running or stopped. You don't see any Docker images. So it is sort of like a clean Docker engine at this point in time. Okay, I have a Docker file. So let's read the Docker file now one more time. It has only one instruction. Each line is an instruction. It's like a command. So it's saying that from Nginx. That means that's my base image. Okay, you can say from Ubuntu, so it'll become Ubuntu. So there is some base image in the Docker Hub repository called Nginx. I'm going to take that. So you need to know that. You can use any. So there are public repositories available for Microsoft, for Google, GCP, and all these things. So you can take any base image. You just need to provide the full URL if it is not the default one. Okay. Let's just see how we can build an image. Now you see that there is no image. So if I say images, there is nothing. Right. So I say Docker build. Because the Docker file is in this folder where I'm running this, so if I put a dot, it works. That's the simplest Docker build command. And it finished. Now if I say Docker images, you'll find an image here because I haven't given any name, so it is showing you as a none. So one of the other ways to give a name is by providing a tag, right, as a command, or you can take the existing image and rename it. So you can say Docker tag the source and nginx wg. And now if you say Docker images, it's going to show you an image with the name. So it's basically rename the image. Okay. You can also pass the tag while doing the build. Okay. I haven't done it because I wanted to make it simple. So now the nginx image is locally available. Now I can say Docker run, and now instead of just nginx, I can say nginx wg. It will run the same local Docker image. Okay, I'll say C, exit. Now that will not give you any difference because I'm using the base. But let's just modify the existing Docker file, which we kind of created. Now the second instruction is that I'm going to copy the index.html, which we created, which is our file, to the default folder. So generally inside the, so you'll find all these details in the Nginx containers documentation. So there's an official documentation available from Nginx where they share the structure and the folder. So you can get that thing. Share Nginx. Why I use Nginx, not other thing, because it's a web, so it keeps running. It doesn't exit until you forcefully do that. Now I also add something like expose 80. And if I just go ahead and save it, it's a very simple, probably world's simplest Docker file. Okay. And if I just say Docker build, now this time I'm gonna say -t and say nginx custom, just to give a tag name. You need to have the build. After Docker, the command should proceed. All right, now this is gonna run this. Now you will find another container in the images section. Second container, that is custom. Again, 8 seconds ago, 10 seconds ago. Both of them are the same size because they use the same base image. It's only a file changes, which is not a significant change. So the MB wise, it's not much, no difference actually. So if I say Docker run, and this time I'm gonna run this with the port mapping. I'll say port 8080 moves to port. This is the Nginx custom. Let's run it. And I go back to my browser and refresh it. Now this is going to change the URL, change the page, because it's now coming from my container, which is the text which I have added, right? If you remember the HTML, that was the HTML I added. Okay, that's why you see that it is now displaying something else. Okay, because I changed. That's your application, the code you have deployed, right? I didn't write any, let's say, rich application using Python, Django, or something like that. But this is the application. All right. Now let me go back and switch. Now let me switch to, allow me to stop. So yeah, now I'm out. So I say Docker images. I see two images, Docker ps -a. You'll find a couple of container in a stop state. Two containers basically. So this gives me the better view. 2 lines. All fine. All okay. Everything looks fine. So let's now probably you can use this custom container and you can push it to your Docker Hub. Now to use the Docker Hub, you need to say docker.io and you can create a login. To see if I can log in. So this is my login. It's a free login you can create. And to do that, I have got many Nginx demo and Nginx videos. I keep using that every now and then, 1 year ago. So what I can do now, first thing first, I need a Docker login. So let me first say Docker logout because I'm already logged in. Now, when I am saying that Docker login, it is asking me the username. So you provide the username you created there, and you provide the password here. Now, if both of them are fine, it is successful. Now I'm connected from this CLI to that Docker Hub. Okay, that's how it's now sort of like connecting. I've said Docker push nginx. So let me find the image names which I need to push. Nginx custom. So if I say Docker push nginx custom, just that. Now what it's gonna do, it's gonna go ahead and move the file of 187 MB to my Docker hub. It's denied. Okay, So I need to rename it based on the repository. So let me rename this. I run another build. I can do a retag, but let's just do a build. Now if I say Docker images, you have this image. Now if I say Docker push, and I say that image, this. Now it's gonna go ahead and push this image to my Docker Hub because it needs that name, right? The repository and the image. Now you can see that significantly large in size, so it might take some time, but based on the internet speed, it should work pretty quick sometimes. So it is almost done, just doing some stuff, and we are fine. Here you can see that a couple of them are there. So if I go ahead and refresh it, you see that I have now the Nginx custom here. So now let me just go ahead and let's say clean up so that I don't have a confusion with what is what. Delete. Just doing it because I just want to make sure that I'm not confused with what I'm doing. So let me copy this name. All right, now I have got this. So let me refresh this. Let's see. So they are all getting cleaned now, deleting. So once it is deleted, so Nginx custom, Ridgecoach Nginx custom is the kind of image I'm gonna use. Now what I'm gonna do here in this, I'm gonna clear up all the containers which are running here by saying docker rm remove. And as I said, like you can just put few characters, 2c3 7 maybe, and then it's gonna delete that, and then it's gonna 5022. So I'll say 5022 is gonna delete that. So you do not have any docker in stop state. Okay. Now if I say docker images, I'm gonna delete all of them. Docker RMI, that's the image deletion. And I say docker images minus q dash dash force. And if I say docker images, there is no images. So right now there is no image in my local machine. There is no container in my local machine, either running or stopped. I'm gonna say docker run minus d minus p 808080, and then I'm gonna say push. I remember notice the name here. Okay, Nginx dash custom. So it is gonna find it and then download it. You can see that now locally available. Download it. Sometimes it says the layer already exists because there was some base images which is it is using. So Docker is layered. It's always very bandwidth effective. Hmm? So it basically can handle those difficult situation of not repeatedly downloading the things which it already knows. Now it is running, okay, in my local machine. So I can go and say Docker, not Docker, localhost 8080. Now you can see that it is coming as custom image. Just to make sure that this is coming from this container, I can say Docker PS. I can say Docker stop, and I can stop the EF0BE. That's probably great gold. Yeah, it stopped. Now if I go back here and refresh it, it's not going to show this page. It will show cannot reach this page. That means it's gone. So my application code is packaged within a container, pushed it to a registry, ready for deployment. Now, in the typical production, we don't deploy things in the Docker engine. Okay, we need sort of like a much more bigger and scalable solution, right, to host an application. Now let's see what are options available. The options available are the container orchestrator, so which will enable me a lot more than just hosting a container, but it's an environment which is a safe playground for my container with networking, storage, security, and everything else you need, right? Monitoring, management, etc. So there has been many container orchestrator. Even Docker has come up with the container orchestrator called Docker Swarm. All these things has happened over a period of time. Now, you don't need to know even the name. That's why I intentionally did not put any name just to confuse you, because now everything is Kubernetes. So Kubernetes is a project started internally within Google. And then in June 2014, Google donated this to Cloud Native Computing Foundation, CNCF. And by donating means they have given it to the organization to use, modify, and in an open source world. And since then, the community has significantly grown. And for anything in the Kubernetes you ask, you will get an answer, right? And then even their community is very vibrant. There's a KubeCon happen across the globe. People do attend that, so it's a kind of very vibrant community. Sometimes Kubernetes is known as K8s. If you count the characters here, so there are 8 characters between K and S. It starts with capital K, A, letter 8, and S. It's a shorter form of Kubernetes. Instead of you typing Kubernetes every time, people do type K8s. And it's a multi-cloud solution. Even it runs on on-premises. So many companies are still running Kubernetes on-premises. You have got fully managed offering available in the cloud. You can even have your own virtual machine cluster and then run the Kubernetes cluster on your own, managed by you in the cloud. So options available for you to use Kubernetes. It has a huge user base, as I said, like, so you don't really worry about whether you don't know the answer or not, but it can give you support the way you want, right? And it has a very frequent update, and supported by big enterprises who are basically sponsoring this development. So you need developer to spend their time. So you need sponsorship also. So when it is a serious development happening, real production workload running, everybody has their own interest to keep it growing and maintained for a long period of time. So the patches and updates, etc., really is helpful. Now, we can go deeper into Kubernetes architecture, how it is placed, um, and then talk about it in detail. But let me give you a very high level pictorial representation of what Kubernetes architecture looks like. So let me switch to my um, drawing board, and let me go back here. So think of it as a cluster, machines, many servers. So it is a big central node. Sometimes we call it as node. Kubernetes, this is a node. This is the central. This is the heart of the Kubernetes system. And then there are smaller nodes called worker nodes. That's where your container runs. So it can be one, two, and as it grows, you can grow these worker nodes. Now in the central one, you have a couple of things which does the monitoring, scheduling, maintenance of all this running container, because it's an orchestrator, right? It's not just a Kubernetes, a Docker engine, or the container engine, right? It's much more beyond that. So we have many technical terms like there are database called etcd, scheduler, health probe, and all these things which are part of this central thing. That's the thing. So it can be one or more. So depending on the high availability you want to set, you can have more central heart system, and then the worker node can keep growing. Now, Kubernetes uses typical object. So they call it the Kubernetes object. There are certain names. And as you know that Kubernetes does not, let's say, run the container directly. Hence, as I said before, that you don't need to actually learn Docker to learn Kubernetes. That's amazing thing, because see, you are running container but you're not learning container. And I have seen many people, right, who doesn't know much or knows anything about Docker command, basic Docker, because they don't get the chance to run those Docker commands. But as I said, like, no knowledge is bad knowledge. So having the understanding of the Docker um, thing is helpful. So let's not get confused. There are many terminologies here, but we will slowly look into it in the real um, Kubernetes world. Now, as the Kubernetes is a setup machine, right, we need some interface to play with it. So there is an API available for you to work with it. And there is a CLI tool also available to connect to that Kubernetes. Let me show you something which is now in the killer coda, as I said. So the killer coda is some way of doing it. So let me just say killercoda.com/learn. Remember the URL, killer coda, killer coda, and then you just get your um, ID created, and you should be able to go into any playground. Now let's say playground, and there are many playground. I'll go to the Kubernetes 1.29 playground. That's the latest version of Kubernetes, which Kubernetes certification is now allowing you to. Now it says start. Okay. Now this is now browser based. It's not running in my local machine. How do I uh, increase the font? I increase a little more. It's a 6. Okay. Now Kubernetes uses a command utility called kubectl, kubectl, people call it. And you can see that there are some commands. Now let me use a little alias for kubectl as k. So every time ctl, I don't have to type the full kubectl. I can say k. It is the kubectl. So now going forward, I'm going to type K. Little more. Okay. Now to see what all nodes are there, so I can say K get nodes. That's the first command everybody writes to check whether the kubectl is working. Because this doesn't require any special privilege. It says that yes, it is able to connect to my Kubernetes cluster. Now, next part comes in. So it is now connected to some Kubernetes cluster, which I'm not aware of. But if you have a Kubernetes cluster, you connect it using the config detail, and then it looks same thing. Maybe the names are different, but it works. Now, the first thing, as I said, that Kubernetes cannot run a um, direct container. So you don't say Docker run here. So just say Docker run. It is not going to run within the Kubernetes because kubectl doesn't have a Docker command. Okay. So instead of that, so I'd say krun because it's coming from Docker run. That's why they have maintained that concept of run. But Kubernetes starts with the, the building block called pod. Okay. So pod is the lowest building block for Kubernetes, which can run the container. So pod actually holds the container. One or more container can be hosted within a pod. So let's say k run and you give a name called web and you say image and you can say Coach. Let's see if it can connect to Nginx custom. It is working. So that means it is able to reach to this image and run it. Now, if I want to see what all pods are running, so I'll say get pods, just like get nodes. So it shows that container is creating. To see in a watch mode, you can see that it's now running state. So if I say that run without watch, so it is running state. So that my pod is running, fine. But how am I access that pod to that? So you can do that k pod, what is the name of the pod? Web exec pod web minus it bin sh. It's inside the pod now, right? And then I say curl http colon localhost, and then it shows the page. All fine. But it's not the way how I want to run my application. So I come out of that. So Kubernetes gives another way of hosting container via pod, but wrapping around deployment. Okay. To wrap around deployment, what we need to do is that we need to create a deployment. Instead of creating a pod, create a deployment. So I'll say create deployment, or deploy is fine, shorter form. And then I say web deploy. Okay. And then I say image equal to nginx. I have just copied it. Now you will see that there are pod getting created automatically with some random name. So right now I have got only one pod. One of one means that I have only one pod running, right? So I have one container running inside that pod, so that is ready. Now I can say k get deploy. That will show me the status of the deployment. So here the one-on-one means is I have only one instance of the deployment. That's why it's one-on-one, not the container. It's not counting container anymore. It's counting pod. Now deployment, as I said, is a scalable solution. So you can do a horizontal scaling. So you can basically increase the capacity. Now to delete a deployment, you can say k delete deploy web deploy. If you do that, the deployment is deleted, which means that it will delete the pod. You can see that that second pod is gone, which was having some random name. Now, if I say deploy, that there is no deployment. Okay, so it's kind of clean now. Now to run the same command earlier as I ran, I say replicas equal to 2. Now if I say k get deploy, you'll find that it is saying that ready 1 of 2. Now soon it will be ready 2 of 2. So ready 2 of 2. So it is kind of ready. So you can see that this is now showing me the list of deployments, only one, but within that deployment, I have got 2 pods running. Now, how do I know that there are 2 pods? You'll find 2 pods. So web deploy is the name of the deployment, dash some random value. Now you can delete one of the pods. Let's say I delete the first pod. So we didn't show you how to delete the pod. K delete pod name. Okay, it's deleted. Copy. K delete pod name. K get pod. Now, why I kept the previous screen is that I deleted 61892. So you won't find 61892, but you will find another. That's what deployment is doing. So deployment is trying to find the baseline, which is that 2 pods needs to be running within the deployment the moment one pod is deleted. And that deletion could happen that one of the worker nodes, if you remember the architecture diagram, is now out of network or it is rebooting. So the pod running there is not available. So deployment will take that number from the health probe and recreate a pod in some of the available nodes. So that it will make sure the baseline is maintained. And you can continue to delete the pod one by one. Deployment will keep creating the pod. Unless you delete the deployment, the pod is going to stay into the system. So that's what deployment is doing. And it gives a lot of strong reason why we should go for deployment, not for pod, because pod is an independent entity, right? And it's not, let's say, managed well the way how deployment manages. Now it's fine. My deployment is fine, but still at this point in time, I can go and do an exec to this pod, let's say this pod, and run the way how I used to run. So let me see if I have the exec showing up somewhere. Yeah, here. And then if I just paste it, it's gonna go inside that. I'll say curl http colon local host, and it shows the same thing. That's not the way I want to run the application. Deployment is maintaining, managing pod fine, but still an issue with access. So what are the ways by which you are planning to expose the thing? So let me now switch to my Azure, okay, and use the Azure Container Service, or AKS, because I then get the public IP from Azure. If you have a public IP, you can configure pretty much here, but let's use the Azure public IP and to expose that thing. So let me see my status of my Kubernetes. Let me start it. Okay. While it is getting started, let me show you a couple of things. Now, Kubernetes also comes with a concept of services, right? Services is sort of like a load balancer, you can think, sitting on top of deployment, cutting across all the worker nodes, right? It's a layer sort of thing, and then the endpoint hits there, and then it redirects the traffic to the necessary pods. So you can create a service by saying that k expose deploy. First, I need to remember what is the deployment name. K get deploy. Okay, web deploy. So k expose deploy, and then the name of the deployment is web deploy. Okay, and then you can just enter dash dash port. Nginx runs on port 80. Let me just say port. Yeah. So now if I say that k get svc, so you can see that there is web deploy name, which has a cluster IP this. So that's the IP address of the cluster. Okay. And uses port. There is no external IP, hence I cannot access it externally. That's why I need my Kubernetes to see. Now let me use this connect statement, go to the Cloud Shell, open. So that I'm just using another, let's say, command window and run the similar kind of command, but in a targeting a different environment, right? So that environment has a Kubernetes which is running in an Azure. So let me paste it. Now I'll say alias, same thing. Okay, get pod. That's okay, that's fine. K get deploy, K delete deploy webhook, web sample, webbook. Web sample. That should clear up my pods. There's no pod. Okay, that's fine. Now gonna run the same set of commands which I ran before. So k create deploy web. Just give them a simple name dash dash image equal to dot nginx custom. Remember that nginx custom is the image which is in my Docker Hub as a public repository. Okay. Now I'll say k expose deployment name, that is deploy web, and then say type equal to load balancer, and then say port equal to 80. Okay, k get svc minus w. Why say minus w? Because it's in watch mode, and you can eventually see that there is a sample. The web is pending, and then the web has got a public IP address. Okay, this is what I'm going to use. So if I go ahead and run this in my browser, that's a public IP address. Okay, it is now pointing to that Nginx uh, application which is running in my Azure Kubernetes service. So your application is kind of deployed as a container using a Docker file, using the Docker registry as the Docker Hub as the registry. You can use Azure registry also, and then running exactly the way you want to run it. So with this, I want to stop here and thank you for watching. And I hope you have enjoyed this. And what I essentially would like you to do is that use the killer coda. That's the playground. And there are a couple of resources which I'm gonna share. So you can just search with the name and then you can get those things. But essentially, you can learn Docker, Kubernetes, etc. without any license cost because these are all open source. You have a laptop, do not have a lot of capacity, fine. You can use the Killer Coda Playground and play with it. And there are a lot of ample of resources available. In fact, I have a YouTube video available which basically talks about that. So I'm gonna kind of share all these links in my comment section so you can just pick it up. It's recommended if you are pursuing for the certification called Kubernetes application developer or Kubernetes admin. You can use the Udemy course, and that's a very good course, by the way. So hope you will enjoy this learning, and thank you again for your time.